Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this part we'll be demonstrating the use of HSM, high-speed machining, and some of their special features. If we take a look at this part, you'll note it looks like a relatively simple part to actually be machined. But notice we have these angles on the walls, and that requires some kind of 3D machining. We'll be using the HSM to do that. Also, what we will show in this part is a problem that we sometimes have is we have a tool that's very, very short, but we want to go into a deep pocket with that tool, just to take out the rough material. But we want to prevent the holder from crashing into the material itself. So let's take a look what we've done over here. If I took my first operation, I have my contour roughing option, my target, and the tool that I will be using will be a very short 30 millimeter end mill. But what we should note over here is this field over here. This field controls the clearance that I like to have, if we look at the picture, between the holder itself and the material that I have to work on. This will prevent the holder actually from crashing into the material. I have my constraint boundary, in this particular case, around the part itself. My passes I'll leave 0.5 millimeters, and I'll go down every 10 millimeters as my downstep. I'll do save and calculate, and then simulate. If I were to do my solid verify simulation, you'll note that the short tool, but because the holder would have crashed in here, the tool path was automatically made further into the pocket itself, leaving bigger steps, obviously. But at least it prevented the tool, the holder, from crashing into the material itself. In my next operation, I still have to clean up those big steps. So what I've done is I've chosen rest roughing and a tool that was 60 millimeters with a 1 millimeter radius at the bottom, but that stuck out a little further. But this tool now will not be taking out a whole full amount of material. It's taking actually a lot less. It'll only be basically working on the steps. Again, my constraint boundary is the same as before. And my previous operation, which is what we use when we have rest roughing, is marked as the actual previous operation itself. My passes, I will still leave it at 0.5 millimeters, exactly the way it was before. And my step time this time, instead of 10 millimeters, would be every 5 millimeters. Now, if I were to use my simulation at this point, again, I'll use my solid verify simulation. You'll note that the tool is only working on the steps itself and every 5 millimeters. And you'll note now that because there is no problem between the holder and the tool, it can go all the way to the end, thereby taking off all the material that's necessary for this particular rough cut. Now in my next operation, I'd like to machine this particular step over here on a finished cut. What I've done is very simply, again using my target, constant Z machining. This time I'll be using a tool that's a 12 millimeter tool with a 5.5 millimeter radius at the tip. My constraint boundaries, the exact same thing they were before. In my passes area, this time I will have my Z bottom on this step itself, which is minus 5 millimeters, and obviously my upper level on top. and I'll be going down every 0.15 millimeters. If we take a look at the simulation itself, and I'll use this time the 3D simulation option, you'll note the tool is going down and machining this wall up until that step itself. Now, in my next operation, I've decided to continue my HSM constant Z machining, but this time working from this point down and these walls over here, and I'll be using the same tool that I used before. If I were to go into my operation, you'll note my geometry, my tool, the exact same tool I had before. My constraint boundaries are still the same as they were before. And in my passes area, this time I'm going from a Z level of minus 62. That if I took it from the part itself would be this surface itself. And I'd be going to the depth of that floor itself of minus 72. Again, I would do save and calculate. And again, if you look at my simulation, you note that it's working on this area over here. And then when it finishes that area, it will work within those pockets over there in itself. Now in my next operation, I would like to use the same tool to finish off the flat floor areas, such as this floor over here and that floor on the bottom. What I'll do is I'll use, again, HSM, but this time I'll use the option of horizontal machining. Horizontal machining is to machine flat floor areas. The tool, I'll be using the exact same tools I used before. Constraint boundaries, no change over there. And my passes, I just leave it the exact same way that the program gave it to me with its defaults. Have my thickness and axial thickness at 0. And if I do save and calculate, and then simulate, you'll note that the tool passes are being created on the floor itself. Now what's left in this part, we still have to do these walls over here. Now if I want, I can use the HSM constant Z, which I will be using, but if I want, I can use a tool that is either a ball tool, or I can actually use a tool that has the exact same taper as the walls itself. So if I go into my operation, I'll be using, again, like I said, the constant Z machining, and my tool will be a taper tool. A taper tool that is top diameter of 20, tip diameter of 4, with a taper angle of 12 degrees. Okay, again, my constraint boundaries is the same thing. My passes, this time in my passes, I want to go from my top, but only up until this floor over here, since the rest I've taken care of already. Now, if we look at my step down, I'll be using a step down of every 10 millimeters. Because we're using a tapered mill, the actual wall of the end mill covers a large amount of the wall of the part itself. So I can take larger step downs. If I were to do save and calculate, and then simulate the part, I'll use the option of 3D simulation. You'll note, let me just slow it down a bit, the tool is actually going in, covering the walls. I'll speed it up a little now. And notice what happens when it gets to this point. At this point, it'll go down to the next area and basically finish the entire wall itself in a few steps, instead of using a ball and mill, having to take smaller steps. Now, if I were to go back into this operation, I'd like to go into my link area for a moment and go into strategy. If you remember, when I did the simulation, when the tool came around to this area over here, it went straight down and then started going across again. If I want, I can go into my strategy area and say, instead of having a straight line, I want you to ramp with an angle when possible. In other words, do something like you see in the picture here. Let's take a look what happens when I do that. If I would run my simulation, again, I'll use the option of 3D. You see the tool goes around, and then when it goes to that area, you'll note, I'll stop it right here, that it tapers its way down till the next step, finishes that step, and then keeps on going down. Sometimes this is desirable to get a smoother finish on the part itself. I'd like to run my simulation now, my solid verify simulation on the entire part. As you see, again, my first tool, clearing out that area. My next tool, taking smaller steps and working on those areas. Clearing each step as it's going in. And my next operation, working only on the top wall over here itself. And again, my next operation, working on this bottom area over here and within the pockets, as you'll see in a moment. And then my next operation with the same tool, working only on the floor areas. And last but not least, my conus tool, my taper tool, working on the entire part, as you can see over here. Going down gradually as it goes around. And finishing the entire part. And here we have now our finished product. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.